Okay, in this presentation we're going to look at the geometric distribution and how we would work with it in R. Now there's one key thing really I want to get across, okay? And it is actually how this distribution is specified, okay? So let's just say for argument's sake that we are interested in the probability of success is 0.25. And the idea of the geometric distribution is when is your first success, okay? After when is first success in terms of number of trials, okay? Now, that seems like a very interesting question, okay? But this actually gets a bit more problematic, okay? Because you actually is also asked it in the way, how many failures before first success, okay? Now, so things, I'm starting to muddy the water here a bit. So just actually, first off, just to recap, if the probability of success is 0.25, how many attempts do I need? How many trials do I need before I actually get a success? Okay, so it's the proverbial putting in the USB key the right way up the first time, that type of thing. Okay, now, so the command is dgeom. Okay, this is the probability mass function. Okay, so 1 and 0.25. So this I think is the probability. I'm going to put a little question mark beside that I'm successful at the first attempt. 0.1875. That is not 0.25. Now the thing is here that this it means really that this actually means one failure before the success. I only need one success, but it actually asks really how many failures did I have before my first success. And that's something you got to be careful about with this distribution. So if I actually was to successful at first attempt, that is actually equivalent to 0 failures before my first success. Okay, that's important. So this is why this is the question I should have asked. dgeom 0, 0.25. Okay, 0.25. Okay, so in terms of what trial is my first success, that is the it's a slightly the question is posed a slightly different way, but that means my first success was at my first attempt. There was 0 successes, 0 failures before my first success. This is now my second attempt. That means that there was 1 failure before my first success, and so on. Okay, you see the pattern going on down there. Okay. Now, actually, just so that's actually the most important thing about you need to know about the geometric distribution with R. Now, because apart from that, actually, it gets fairly regular. So what I'm going to do here is actually just show you some other commands that you can actually have a range of commands. So 0 to, let's say, 5. Probability is 0.25. There we go. That's just a range of values there. Okay. And for example, you can also use the pgeom. That means I guess it's within a certain number of attempts. Okay. So yeah, so the sample space there for this distribution. Oops, let's go back there. Just clicked on something there I shouldn't have. So the sample space for this distribution is 0 to infinity. Okay. So PD. Now you can also do the rgeom. Okay, that which is just to randomly generate let's just generate 20. Okay, 0.25. There we go. I'm not like, I mean, there are many applications where this is useful. I can't think of any off the top of my head. So there's also actually qgeom, 0.5, let's say 0.25. But I don't really think that's particularly useful. I'm not a big fan. Well, actually, the inverse cumulative functions are not particularly helpful for discrete random variables. Okay. Well, they're not completely useless, but they're you would use them more so for on the basis of continuous random variables. Now, that's just a very important point about the geometric distribution. Now, let's just say, for argument's sake, let's just check a few things here. I might have to just put, like, I just actually called the help file there for a second, because I think there's one more remark I'm going to make here, and it's actually sort of adjusting from the what I thought I should have had. Okay, I'm just going to pause this a second, actually. So that's the help file there. Actually, I thought I was going to mention something there, but I didn't. I can't remember what it was. Doesn't really matter. So actually, when you do read the help file, it actually does actually explicitly say vector of quantiles or vector or R quantiles representing the number of failures in a sequence before in a sequence of Bernoulli trials before success occurs, and the probability of vectors or whatever. So that is it actually is crystal clear, but actually when you actually read it in the help file. But again, this was something that was not familiar to me, and drove me nuts for ages. I thought it was going crazy. So we'll leave it there.